What is nuclear? The simple answer given by student energy is the energy held in the nucleus of an atom. It can be obtained through two types of reaction, fission and fusion. Salut tout le monde, merci d'être ici. My name is Julia, and alongside me is Bandana, Stella, and Tessa. We are Vincent Massey seniors who are here to talk about effects of nuclear mining, waste, spills, the power on the environment, and the Indigenous people. To begin, let's go to the beginning of how this all starts. Mining. Fission is energy the nucleus produces through splitting into atoms. Once split, they release heat energy, which generates steam. This process can then be used to turn a turbine to produce electricity. In today's world, we use fission for all nuclear plants to generate electricity. While uranium is the main and most valued mineral, other elements can be used for this process, such as plutonium or thorium. Fission whereas with fusion, it is the nucleus reaction where two or more atomic nuclei collide at a high-speed level to then merge into a new type of atomic nucleus. Through this process, matter is not being conserved because it is being used to convert into a new atom, meaning this additional matter is then being able to create energy. In terms of waste, fusion isn't that remarkable simply because the energy it creates affects the sun and stars rather than affecting electricity. Uranium has become one of the world's most valued energy minerals. What is it, though? Uranium is a naturally occurring radioactive element. It has been mined for thousands of years to use for chemical properties. The principal usage for uranium is with nuclear reactors to create electricity. Such as most things, there are multiple ways to mine. With uranium, there's a conventional way by mining the rock or by using strong chemicals to dissolve uranium from the rock. There's open pit mining versus underground mining. Suffice to say, there are multiple ways to extract uranium. United States Environmental Agency mentioned that regardless of how uranium is extracted from the rock, the process leaves behind radioactive waste. Around 80 to 90% of radioactivity is left behind after mining. This is called tailings and raffinites. The environmental impact they cause is water contamination, land degradation, and ecosystem disruption. Keto says that adopting efficient tailings ponds practices is essential for minimizing environmental impact, improving mining efficiency, and promoting sustainable resource management.
But peace always has a price, right? Yet it's never the ones who order these weapons to be dropped that pay it, because the same skewed logic that believes nuclear weapons are beneficial to life finds that in order to end the sufferings of one group of people, the continuation of a centuries-long culling and displacement of another is necessary. Indigenous people were not told of uranium's lethal effects, despite them first being documented in the 16th century. At that time, long before these effects would be identified as lung cancer, they were called the Schneeberger disease or mountain sickness, and were confirmed to be caused by ingesting radioactive materials by the early 20th century. So they knew, and they let Indigenous people such as the Delaney work in their mines with no PPE to satisfy their arms race. This lack of information led the Delaney people to sleep atop the ore, to sew tents out of uranium sacks, and to eat fish from contaminated ponds. The high number of deaths that resulted earned their community the nickname Village of Widows. To add insult to injury, they were also not informed the uranium they were mining would contribute to the Manhattan Project and still feel the guilt, albeit misplaced, that weighs heavy on their community. Today, mines all over North America still haunt Indigenous communities as they've been left unsealed, allowing them to continue their assault on the lungs of nearby people, contaminate water and soil, and ignorantly be used to build homes out of remaining materials. Furthermore, the lack of access to healthcare within reach of some of these more remote reservations allows the lethal effects of uranium to thrive, which have since been proven to not only include lung cancer, but various other kinds as well, in addition to kidney failure.
So, what is the waste from nuclear weapons? The waste created by the detonation of a nuclear weapon is labeled as radioactive fallout because the cloud created by the explosion picks up particles, dust, and debris that eventually falls out of the cloud and back to the ground as radioactive material. I want to start by talking about deposition. Deposition is the process where particles, gases, and sediments are moved to a new location. There are two types of deposition when it comes to radioactive material. The first type is dry deposition, which is linked to the near-surface concentrations of radioactive material and is often the larger particles. The second form of deposition is wet deposition. As opposed to dry deposition, this process includes precipitation and is typically the smaller particles, hence another name for it being precipitation scavenging. Due to the size of the material in question, dry deposition dominates the local vicinity of where the nuclear weapon was detonated. Small particles, on the other hand, can reach higher altitudes where they can be carried longer distances before becoming subject to wet deposition, leading this process to dominate regional and global deposition. These processes lead to regions not immediately impacted by a nuclear explosion becoming contaminated with radioactive material. The first type of environmental contamination I'd like to talk about is water contamination. All surface water in surrounding communities and ecosystems could become contaminated with radioactive material. Iodine-131, with its short half-life of approximately 8.06 days, would be present within the first few weeks post-detonation, and strontium-90, with a much longer half-life of approximately 29.1 years, would remain in dust that then contaminates water sources such as lakes, rivers, and other bodies of water. While underground water sources would initially remain clean, they could become contaminated, and they would remain that way for years to come. Contamination of this sort can have immense impacts on our aquatic ecosystems. When water is contaminated with radioactive material, the radionuclides will accumulate in the food chain. A consequence of this is biomagnification, where one organism has a level of contamination due to ingesting other plants or animals where the toxins are more dispersed. This would lead to predators at the top of the food chain of these ecosystems to having higher concentrations of these toxins, potentially impacting the biodiversity and stability of these ecosystems, as well as leading to a higher risk of genetic mutations, developmental abnormalities, and altered reproductive cycles. Another form of contamination is soil or land contamination. After the detonation of a nuclear weapon, fallout particles can contaminate the soil, plants, and wildlife. Similarly to aquatic ecosystems, these toxins would make their way through the food chain, first to the fields and plants, they would become contaminated, then the animals. Wild animals and livestock could become ill, die, or pass those toxins on to us. We could see the same bioaccumulation and biomagnification in our land ecosystems that we might in our aquatic ecosystems. These are just some examples of how how radioactive material can spill into our environment and the potential effects on the planet we call home.
Most Indigenous communities have holistic worldviews and believe that everything in nature is interconnected. Their land is their life, their source of food and medicine, meaning an attack on the earth is an attack on them. Being separated and displaced from their land, especially because it's been polluted and contaminated, means burial sites have been disturbed, native vegetation used for medicine and ceremonial practices have been removed due to radioactivity. Communities no longer even have access to areas important for traditional practices at all, and therefore can no longer perform prayers and ceremonies. Nuclear waste has crippled their way of life by taking their ability to live off of it. For example, in 1979, a dam located on the Navajo, or also known as the Diné Reservation, broke, causing the largest spill of nuclear waste in U.S. history. The Church Rock spill, as it was later dubbed, endangered the Diné people's way of life by killing all of their livestock and contaminating their water resources. But the devastation was far from over. Cancer has wreaked havoc on their community, their only chance of survival requiring them to lose more of their culture, their hair. On top of that, for generations, Navajo neurohepatopathy, a disorder caused by uranium exposure that disproportionately affects the Diné community, has claimed victim after victim. It causes a decrease in movement due to nerve damage and muscle weakness. It causes open sores on the cornea, birth defects, and potentially fatal liver problems. They cannot escape by relocating due to economic and cultural reasons and due to the hereditary nature of such conditions.
Finally, we'll talk about the results of an explosion and how these disasters impact our environment. After a nuclear explosion, the air gets contaminated by something called a mushroom cloud. A mushroom cloud is extremely hot debris, water vapor, and smoke. This cloud of gas can get as hot as the sun. 3,871 degrees Celsius is how hot Hiroshima got after it got bombed. Alongside mushroom clouds, many fires spread throughout, not only the community, but also nature. Both the gas clouds and the fireballs lead to the burning and melting of buildings, forests, and anything else around the area of the explosion. Another extreme consequence of nuclear explosions is the radiation. Direct radiation is one big blast as the nuclear explosion explodes. And within a matter of seconds, the area that the direct radiation occupies doubles and doubles. To put direct radiation into perspective, Little Boy, that bombed Hiroshima, began its nuclear fission, the process that emits radiation, within 0.15 microseconds. Just like Tessa mentioned, with nuclear waste, radiation causes the DNA of plants and animals to be altered. This creates genetic mutations and affects the chain of life of plants and animals. Now the question is, what happens if we don't stop using nuclear weapons? The point of this conference is to understand the impact of nuclear weapons and why we should never use them in the future. But it's also important to understand what new problems could be created if countries keep on producing these weapons. Already there are terrible consequences that we've talked about during this presentation, but scientists did research and came up with the theory nuclear winters. So what is a nuclear winter? Scientists believe that if there was ever a nuclear war with many weapons, way too much smoke and dust would get into our Earth's atmosphere. This layer of smoke and dust would cover up most of the sunlight we get, causing the temperature to lower. Scientists believe that eventually the temperature would go below freezing point, meaning we'd have to spend a long period of time, or maybe even forever, in the cold and darkness. If a nuclear winter were to ever happen, and it doesn't seem unlikely, most of us wouldn't be able to adapt. Our crops would be frozen, we would be freezing, many of us would die. Up until this section of our presentation, we've talked about current effects on the environment, but nuclear winters show us a new reality if we don't take nuclear weapons seriously. The environment has given us many signs for decades now. If we continue to ignore all the fires, the gas, and the contamination, we may have to get used to living in a world with nuclear winter. Thank you.